Hello, my name is Jared Semler. This is my video submission for lab number 9, the projects lab. I'm going to go ahead and start this video by explaining the core concept of what I tried to do here. I tried to essentially simulate a version of baseball or like a speed game with the ball. So right here I have my potentiometer that controls my servo. And once I spin the potentiometer, the servo will also spin, hitting the ball. Once it hits underneath of here, the ultrasonic sensor will detect that there's a change in distance from the ground, which is initially around 9 centimeters, to the ball hitting it, which is around 8 centimeters. So once that happens, it'll set off this speaker. Before I go into any of the code for this project, let me first start by giving a little demonstration. So when I turn this potentiometer, it's going to swing the arm of the baseball and hit it underneath here. Once the ultrasonic sensor detects that the ball is underneath of it, it sets off this speaker. Now I take it out, and now it turns off. You can also see here that I have this battery pack. That's simply to make sure that my computer isn't eating up too much of, giving off too much of an energy source. I'd rather just have it come from a safer source. So now that you've gotten a little demonstration of what the physical property is, let's go over what the servo code does. So first here, this is just defining a lot of my global variables. The trig pin and echo pin, those both work for the ultrasonic sensor, the speaker, that's self-explanatory. And these are just some defining integers that will be important later on. Down here, this is just where I set the pin inputs and outputs. And then now it's time to go over the meat of the project. So right here, that's just setting this is basically what runs through the servo code and how the potentiometer connects to it. And then down here, this is the beginning of the ultrasonic sensor code. And it carries on through here. That's just essentially setting it all up so that it detects exactly what the distance from the ultrasonic sensor is. Now, if I move down a little bit, this if statement here is saying that if the distance is less than 8, and this is for the ultrasonic sensor. If the distance is less than 8, then the speaker is going to be on. And then that's how you know that the ball is underneath of it. If the distance is greater than 8, it means that the ball is not underneath of it. Now down here, if this time end statement, that's just essentially setting the serial monitor to stop at 15,000. And then this if statement for potentiometer pin, if it's greater than 0, that's when I want my timing to start. And then if the distance of the ultrasonic sensor to the ball is less than 8, then I want the time to end, and that's what the serial printer is going to print right there. And then it's going to carry over to the processing code. Now, the processing side of things is pretty simple. I took some stuff from prior labs that we did this semester. I uploaded a background image up here, and then down here I just inserted some text. And throughout here, this is the bulk of it. So this is where it strings, and this is where it reads what I want it to do in a certain scenario. So let's go ahead and run it, and we'll talk after that. So this is the screen that I've created essentially that pops up. And now you'll see when I hit this, goes underneath. If it's not underneath a certain time increment, then there will be no display here. However, if it is underneath a certain time increment, it'll display home run, and we'll go ahead and display that next. So now this one displayed a little faster, or this one moved a little faster, so I got a home run on this one. Thank you, and that is it for this lab.